grams. Then what happens is that water molecule goes away. And what you're left with is an even bigger polymer, or if it was two monomers before this, then you have your starting polymer. So it would look something like this, down here at the bottom, right here. So what is this kind of reaction called? Well, because we're losing water molecules in the reaction, it's called dehydration synthesis. Now, this is a really, really important reaction because this is how a lot of polymers are formed. So, there's one other kind of reaction we need to learn about, and this is called hydrolysis. It is essentially the reverse of dehydration synthesis. So, what happens in hydrolysis is you have your polymer that is connected, and a water molecule gets pushed towards it or shot towards it. And then that water molecule is going to break apart the polymer back into either its separate polymers that it was part of beforehand or into its separate monomers, depending on how large it was. So, now we've covered a lot. We've covered carbs, basic and a little bit more advanced macromolecule structure. So now we're going to move on to our second macromolecule, lipids, fats. Well, mostly fats, but there's some other, they come in some other varieties. So, as I mentioned earlier, you hear lipids or fats and probably think they can't be necessary. People always talk about not being fat and don't eat fats and things like that. Well, I'm here to show you just how important lipids are and to show you how much people have misused the term fat. Anyway, what are lipids? Lipids make up fats, sterols, and phospholipids. The weird thing about lipids is they don't really have a specific monomer, and thus they kind of don't have a specific polymer. Now, they have multiple different monomers, you could say, for each kind of lipid, which make up large macromolecules, which can be considered polymers. But they aren't as straightforward as the other macromolecules are. For example, fatty acids and glycerol heads make up, I'm going to butcher this, triglycerides, or fats. Anyways, lipids are really important to life for a couple of reasons. One, as I mentioned a ton, they make up fats. And so why do I think that fats are important for life? Well, fats, first of all, as I mentioned earlier, serve as a long-term energy storage kind of molecule. So all of the fat in your body is like an energy reserve, like a backup battery. So when you run out of immediate energy, like carbs, you have something to rely on. Another really, really good thing about fats is they serve as insulation to keep your body warm, especially during colder months and seasons such as the winter. So, let's first now look at fat and triglyceride structure. Fats are composed of, as I mentioned earlier, a glycerol head and 3 fatty acid chains. So, actually, not sure if I mentioned that earlier. I believe I did, but just in case, I'm going to draw it for you. So, here, I'm going to put a G inside it just so we know. There's our glycerol head. See him? Alright. And then we have these 3 fatty acid chains. 1, 2, 3. So, this is a fat. Now, it kind of looks like a really weird sideways jellyfish. That's how I like to remember it. So, as I mentioned, they serve as long-term energy sources for animals and insulation. So, fats come in 2 varieties, saturated and unsaturated. To understand the difference between these two, we need to look back at their structure. So, this would be a saturated fat, right here. Now, why would it be a saturated fat? Well, first, we need to understand that this is mostly made of carbon in here and hydrogen, all of these fatty acid chains. So, A saturated fatty acid chain is completely straight. This makes it really, really good for being compact at room temperature, and thus it's solid at room temperature. But saturated fats have a little bit of an issue, or unsaturated, excuse me. They don't have straight fatty acid chains. Their chains are very crooked and zigzaggy. And the reason for this is because in the fatty acid chain, there's an extra double bond, which forms these kinks in the chain. Like this. So, unsaturated fats, these kinks in their tails make a really big difference in the way they are, what state they're in at room temperature. They're liquids because these chains can't be as tightly compacted together when you squish all these fat molecules together. So that's the main difference between saturated and unsaturated fats. As I mentioned earlier, fats are only good for you in moderation, just like anything else. If you eat too many fats, what's going to happen is you're going to have a huge amount of energy storage, but you've seen it before, it's going to store as fat. This is when issues such as obesity start to happen, because people have so much fat that it becomes unhealthy. So now we're going to move on to sterols and phospholipids, the second and third kinds of lipids there are. So I'm going to start with phospholipids. What do they look like? Essentially, they're just a fat molecule with only 2 chains instead of 3. So phospholipids' main job is to be part of the cell membranes of cells. So what they do is they form this kind of wall structure with their heads on the end, and the chains on the inside pointing into each other. I'm trying to draw this quick so the kinks in these chains aren't going to be the best, but and this phospholipids are governed by a really important principle of lipids. And this is that they have a hydrophilic end, meaning they love water, that end of them, and then they have a hydrophobic end, which means they hate water, water hates them, they stay away from each other at all costs. So, when these phospholipids align to make cell membranes, their heads align on the outside, because typically that's where liquids like water are. So they align by the water because they like the water. And these phospholipid tails, these fatty acid tails, all align on the inside because they hate the water and they're trying to get away from it. So using their heads, these phospholipids make a wall and allow things into and out of the cell. So our final kind of lipid is the sterol. You've probably heard of sterols before. Cholesterol is one kind, steroids are another. They mostly serve as structural support and help with things such as growth of living organisms.